Okay. Hi guys. How are you today? Trust you're doing very well. Alright, so welcome to another session and another day of the Tableau Bootcamp. My name is Michael Fajimine. I wouldn't even know where to start introducing myself. But then if you want to know about me, you could just look me up on LinkedIn. And if you have any questions about this particular session, you can as well, ask through any of those platforms. This is my LinkedIn, this is my Twitter, and you can, hit me up with my email. I'll always answer your questions. And if there's any other thing you want to know, I'll always be there to answer you. So, the topic for this session is data preparation with Tableau. Right. Data preparation. When you hear this, what comes to mind? Data preparation is a very, very critical aspect of analytics. When you're looking at the analytics cycle, you collect your data. The next thing you want to do is you want to prepare your data. You don't collect your data and then the next thing you start, um, you know, analyzing your data, creating visualizations, or starting to, create a predictive model. The next thing you want to do after you've collected your data is to prepare your data. Go straight to data preparation. Why do you do that? You do that so that you could ensure that your data is of good quality. If your data is not of good quality, it's going to affect your end goal negatively, right? So that is the reason why data preparation is very critical, very, very essential, right? And before I proceed, I would like to let you know that Tableau actually has a dedicated product for data preparation, which is called the Tableau Prebuilder. But then, Tableau still makes it possible for the Tableau public and Tableau desktop users to be able to do some data preparation within this applications. All right, so without talking too much, don't let me bore you. Let's just dive right straight in. So, Tableau preparation. We are under Tableau preparation, data preparation. Pardon me. We are going to be looking at these topics. Data cleaning with interpreter. There's a feature in Tableau called the interpreter. Right. We are going to be looking at how to restructure your data with pivot. We are going to be looking at how to combine tables or how to combine data with joins, relationships, blendings, and union. So right now, I am not going to assume that everyone watching this video right now, is not new to data. So my assumption right now is going to be, as we have people that are not new to data, we also have people that are new to data. In fact, this is going to be their first, webinar, right, to learn from. That is going to be my assumption. But then for people that are not new to data, I want to believe that so many of those concepts are not new to them. When talking about pivots, talking about joins, talking about unions, because these concepts are not native to Tableau. But then still, I am going to do some, I'm going to touch on the basics of all of those things. It's going to be refresher to some, why it's going to be, very new to other people. Okay, so we're going to be touching them one after the other, starting from the data cleaning with interpreter, right? What is the Tableau interpreter? So the Tableau interpreter is, it's a feature in Tableau that is streamlined to do all of your data cleaning tasks for you. You don't need to stress, you don't need to break a sweat over anything. All you need to do is just, click, and with a single click, all of your data cleaning tasks are streamlined. They are done automatically. Everything is done, right? And then we have pivot. What is pivoting in Tableau? How does it work, right? So pivot is an operation that allows you to reshape your table, right? It converts your table. There's something we call the wide table and a tall table, right? A table in a wide format is not a table that is good uh, for creating visualization. It's probably good for, if you're just going to look at it visually, but for creating visualization, a white table, a table in a white format is not, is not suitable. And I'm going to show you that when we jump to Tableau in a bit. The tall table is regarded as the most suitable format for data visualization, right? So it's like you have this is what we call a wide data format, and this is a tall data format, right? So just let's dive into Tableau and have some fun. It's there you're going to see some of these things instead of doing a lot of talking here. So what am I going to do? Right here, I already brought in my data here, but let's close this and open it from, start from opening a Tableau. Pardon me. Okay, so I'm going to open my Tableau public. And while it loads, I am going to show you the data we will be using, right? So this is I've created some data here, different data sets. They're actually fake data though. Just for the purpose of demonstrating everything we're going to be looking at today. All right, so I have this interpreter and pivot. So I've created I've created two different use cases here for just to demonstrate the data interpreter, how it works, right? So, most often than not, if you work with teams, you would see situations like this where in a single Excel worksheet, you have different tables scattered everywhere. You have 3 tables, you have 5 tables, you have 10 tables scattered everywhere. And you as a person, you just want to, be very fast with what you're doing. You don't have that time to, start copying and pasting into new sheets and trying to make things easy for you. But you know what Tableau said? Tableau said, don't worry, I got you. I'm gonna do that for you. All right. So this is the first use case of data interpreter we're gonna touch. The second use case is, looking at a table like this table is actually, I formatted this table, having a title. This is Indian states by population. You can see different census that were carried out in different years, right? I think the census is every 10 years, right? And these are different states in India with their population. So different issues with this table. The first issue I can see here is the header is repeated. We have the duplicate header here. If you come here, we have some NAs here, which actually means that this particular state of Telangana was not created on this particular years. There we have another NA here. Then what else? Okay, I think these are some issues we have with this particular data set. So we are going to clean this up in Tableau in a second. So I'm going to go back to my Tableau public and connect to the data. All right, this is interpreter with pivots, interpreter and pivots. That's what we just saw. So we're going to see what it's going to look like when we preview here. Now, these are the two tables. This is the first table. This is the second table. Now, somehow, Tableau has created two more tables, two additional tables here, right? Why were these two tables created? Okay, I'll show you that. I'll tell you that in some second. But let's preview these two tables, right? So this is the first table we have here, the 3-in-1 table. Dragging the 3-in-1 table here, we could preview that. Tableau actually treats, as expected, is treating this particular sheet as a single table. You can see between the first table on the sheet and the small table on the side, we have some nulls here. Like, okay, this is a single table as Tableau is interpreting it to be. And then down here we have another table. This is a new header, which signifies the beginning of another table. Right, that's the first table. Now let's see the second table here, the population table. Right, on the population table, you would see that for the header, look at what Tableau has done. Tableau is seeing the topic we actually gave the table, the Indian states by population. Tableau makes the header. Meanwhile, that is not the header. That was just the topic. And then for the other columns, it has chosen to use some alphanumerics as the headers. You can see F2, F3, F4, F5, I think to F7 or F8, right, to F8. Meanwhile, it is neglecting the real errors, which is here. And coming down, we still have our NAs. I mean, we need to take care of all of these things. And then our duplicate header here, we need to take care of that. Right, then going to these two extra tables that by default Tableau created for us. If I drag this here, you see that this table was created from the 3-in-1 table. As you can see, as a prefix, it says 3-in-1 table sales team. Okay, so this table was created from this table. So somehow Tableau looked at this table and thinks, of course, I can see something not right about this sheet, right? I can see something not right about this sheet. This sheet contains a lot of tables, and then somehow Tableau extracted one of the tables. But I mean, we there are three different tables there. But of course, I mean, Tableau tried and said, okay, this is probably what you need, but we need more than this. Then again, from the the population table, Tableau by default again created another sheet, another table rather. Right, so we'll try to figure out what we might be looking at, but this is not enough. I mean, we still have duplicates here, and coming down, we still have our NAs here. We don't want all of those things. So what we're going to do is we are going to use the Tableau interpreter to actually clean up these two tables properly. So what do we do? All we need to do is just check this box that says Use Data Interpreter, and look at what happens. It loads, and voila, we have a cleaned up table here. Now, Tableau has created three additional tables for us. Right, great. Tableau has created three. Now let's take these three additional tables, right? If I take this away and I look at it, you can see from the title of this, from the name of all of these tables, you know where these tables are actually coming from. We have the 3-in-1 table and the Excel coordinates, right? We have 3-in-1 table. Let me scroll down. You have the 3-in-1 table and the Excel coordinates, 3-in-1 table and the Excel coordinates, right? If I drag this table here, you see that Tableau has actually separated all of those tables into new sheets, right? Just by clicking on the data interpreter, Tableau has separated all of these tables into new sheets, which is what we exactly want. Wow, this is great. All right, then this is the last one. Okay, I'm not sure why this is going slow. Okay, we're gonna update that automatically. All right, so this is the third table right here from the 3-in-1 table. So somehow Tableau has actually helped us create three new tables from those tables. And right here we have the population sheet. Let's see what Tableau has done to the population sheet. Now, great. Tableau finally promoted our header and then it removed the duplicates. Now let's see what Tableau has done with the NAs. Great. Tableau has turned all of the NAs to nulls. So now, I mean, it's easier to work with nulls than NAs. We can see, I mean, then here it has turned the NA here as well to null. So this is exactly what we want to do with our data. So I mean, just using the data interpreter feature, Tableau has done all of the cleanings we want for us. And one other thing Tableau has done for us is it has actually looked into different of all of these fields, right? And I mean, it has given them the appropriate data types. Now look at this. These are states, and look at what Tableau has done. Tableau has given it a geographical data type. Look at it. I mean, by the icon you can see this is a population. Tableau has given it a numerical data type and across the table. And Tableau has done the same thing for the other sheets. If I drag this down and drag the other sheets in, you'd see that Tableau has actually, you know, done exactly what we want. These are strings, these are strings, these are strings. This is a data type, a this data type, pardon me. I mean, everything we want, we could have done ourselves. Tableau has streamlined it just by clicking the data interpreter. Great. So now that's about using the data interpreter. We are now going to jump into using pivots with Tableau. How does pivot work? Now look at this particular sheet, the population table. There's something not good about this table structurally. I mean, uh, when we were talking about pivot, I mentioned that pivot basically converts a white table into a thin table, right? This is a white table, and white tables are not good for data visualization. Of course, merely looking at this table, you'd see that Uttar Pradesh has, this population, for this year, this population for this year, this population for this year. But when it comes to actually creating visualization out of this, it's going to be very difficult. It is going to be very difficult. So, when I say this particular table doesn't have a very good structure, what do I mean? All right, when you want to, when you're talking about very good data structure, there are some points you should actually consider. The first point is you want to ensure that the measures in your table are in the same level of detail of the table. Now, if you're looking at this table, these measures, are they in the same level of detail of this table? No. The level of detail of this table is state, as you can see. It is state. So it would actually be appropriate to have a state and a population. A state and a population, because state is the level of detail of this table. But what level of detail are these measures? These measures are in level of detail of year, not state. So the level of detail of this table, of the measures in this table, it doesn't make sense, right? The other thing you want to ensure is that measures or dimensions, fields, a single field does not repeat itself in the table. That is, the same dimension of the same measure does not repeat itself in the table. But if you look at this, we have population repeating itself across different fields. This is a population. This is a population. This is the same population. This is the same population. And this is the reason why we have a white table. Now, if I'm saying white tables are not good for data visualization, and you want me to actually demonstrate that for you, I will. Now, look at this. Let me open a sheet for you. And probably right here, you'd see that we have measures scattered all over the place. If I drag this into my screen, I just have, the same measure. Right, so what happens if I want to answer a question such as, I want to see, or what is the change in population over years? How do I answer this? Because to answer these particular questions, I need two different fields, right? I need the year, because I want to see change in population over the year. So I need the year field. Another field I need is the population fields. The population field, rather. But I do not have these fields readily available here. Even though I have them inside my table, but I don't have them here. I don't have the year field here, and I have my population scattered everywhere. So how do I create that kind of visualization? I just can't. It's very, very complex to do. So, like I said, I have these fields I have in my table. All I need to do is just restructure my table, and then I will be able to actually answer these questions. So I am going back to my data source right here. This is my data source. In order to pivot this, to use the pivot to restructure this table, I am going to select all of this repeating this repeating field, which is the population. I'm simply going to select, I'm going to right click and go to pivot. This is pivot. Once I choose pivot, look at what happens. The numerous fields has been converted to just two different fields, and the level of detail of this table has changed to what? It has changed to state per year. Look at what we have. It has changed to state per year. So now we now know that each row here, each measure we have here is in the level of detail of states per year. So we know that 60.2 million was the population for Uttar Pradesh in 1951, and this is easier to actually make a data visualization. So like I said, it has created two new fields for us. We can easily rename this, double click this and rename this population. And we still have a situation here. If you look at this particular field, it contains the year we want, right? This should actually, we could have converted this to a data type, but it can't. It's not possible because we need to first extract this year, which is actually part of data cleaning process, right? How can we do this? If you click on the top of this field and you right click, it gives you different options here. You can use the split, you can use the custom split, you can create a calculated field. In order to extract the year here, if I use the split, look at what happens. Somehow, Tableau thinks this is what we might be looking for. Tableau actually splitted this and gave us the year field out of this, which is actually very great. Right, another way to actually do this, just in case the split option does not work the way we want it to work, we can come here, use the calculated field. Now, if you're used to Excel, this is a very simple formula in Excel, which is the mid formula. If you use the mid formula, all right, which in IntelliSense is with the mid formula, you need what? You need the string. What string are we looking for? The pivot table field. That is the title of this particular field. All right. So after that, what do we need again? We need the start, right? So it's saying where do we want to start counting from? And since all of the length of all of the values inside this particular field, this particular column, are consistent, so we can start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the one starts from the 13th, and the size is 4. 1, 2, 3, 4. So we can use 4 and close the parentheses. Now let's see what we have here. Okay, we can rename our calculation here. We can rename it split. All right, then let's apply and let's see what happens. Great. So somehow Tableau has actually splitted this for us. It has, through the calculation we wrote, Tableau has splitted this for us and gave us a new field as the year. So since we don't need this anymore, we can just, hide this. Great. And we can rename this the year. This is easy. We've been able to, clean up the population table. And then if I come here, look at what happens. Now we have the two fields we need, which is the year and population. Now we can answer our question, right? And we can change the year. We can change the data type of the year, right? We can change it to, the data type, and we can, make a visualization out of it. We can drag population here, and easily we have exactly what we are looking for. So we can, from here we can tell that population has been increasing over the years in India. Great. So that is that about using data interpreter and using the pivot. Now we're going to go to how to combine tables in Tableau. Right? We have different ways of combining tables, and I am going to explain how these things work and the differences between all of this, different ways of combining tables. So if I go back to my slide, one of the ways of combining tables is what we call the joins, right? Like I said, some people actually, familiar with the concept of join, right? How join works. So a join is a technique for horizontally combining data from different tables into a single table or data set, right? So you're combining different tables side by side. Probably I have one table that contains, employee ID numbers, but doesn't contain employee names. And I have another table that contains employee names, right? So now I am trying to, combine these two tables so that the first table that only combines the ID number, I want it to also carry the names of the employee. What do I do? What I can do is combine these two tables, all right? So that is exactly how join works, right? So you're combining two tables to make one table. And there are different types of joins. We have the inner join, we have the left outer join, we have the right outer join. Pardon me, this is the right outer join here. We have the right outer join and we have the full outer join, right? In a second, I will tell you, I would explain all of the types of join to you. But then when talking about join, like I was trying to illustrate a minute ago, that a join could occur between two tables where you're trying to consolidate a table with information it doesn't have, with the information from another table, right? But before two tables can actually join, they must have something in common, right? It's like two people coming together, a man and a woman, they want to get married, and there must be something that actually interests the both of them, right? That is what we call a common field. So for two tables to join, they must have a common field that exists between two of them, which is going to be the basis upon which these two tables will join, right? It's going to be the basis upon which these two tables will join. And these common fields are called the linking field. Okay, so if I continue here, this is the inner join. This is what inner join. So right here we have two tables that are trying to join. We have table A and table B. Now these two tables coming together to make a single table, like a single entity. Now, how does inner join works, right? Inner join, like I mentioned, for two tables to join, they must have a linking field, right? Now, these two tables, this is the linking field. This is the linking field they have. Now, which of these records match? So basically, inner join combine only matching record between the two tables and form a new table out of them, while the records that do not match are truncated. So if you look at these two tables, Paul matches a Paul, Mike matches a Mike, Idris matches a Idris, Abisola has a match, Bola has a match. But look at CD, doesn't have a match, Adekola does not have a match, Okafor does not have a match, Godfrey does not have a match. So for that reason, these four records were actually truncated. Only these 1, 2, 3, 4, 5 records were in this table. That is exactly how inner join works. And then what about left outer join? For left outer join, right? Left outer join looks at the first table. The first table in your join is always the left table, while the other table is the right table. Right? So how does left outer join work? Left outer join looks at your left table. It takes all of the matches, all of the records that match with the right table and records that do not match with the right table. It brings them into the new table. While on the right side of the table, it only takes records that match. So that is how left outer join works. So it's like from the left table, you're lifting all of the records, while on the right table, you're only lifting records that match to form a new table. Right? There are different use cases for that. And then we have the right outer join. The right outer join is the opposite of the left outer join, where you are preserving all of the records from the right table, while you are only bringing in records from the left table that match. And then we have the full outer join. Now the full outer join doesn't care about records that do not match. It's lifting all of the records from the both tables. So right here we have all of the records that match, plus records that do not match from the left tables, and the records that do not match from the right table. As you can see, the records that do not match from the left table, they don't have any matches. So we're just going to have nulls here. And for the right table, the records that do not match as well are going to have nulls from the left table. Right. So what are the characteristics of join, right? So, for you to understand joins, we're going to talk about two concepts, right? We're going to talk about concept of physical layer, and we're going to talk about concept of logical layer, right? I think it's just appropriate I show you all of these things on Tableau. So we're going to jump back to Tableau right now, and we are going to connect new data sources and understand how join works. All right, just give me a sec. I don't know why. Okay, so I'm going to come back to my computer, and I have okay, so I have this here. So I have two tables here. I have a sales table and I have a contract table. All right, just to preview what these two tables look like, I'm going to open them in Excel. So right here I have my contract table, which contains different contract IDs. So each record of this table represents different contracts, right? And then we have employee ID, we have the name, so which means that the same employee can sign one contract and can also sign more than one contract, right? And then the sales table is the sales of each of the employee. Pardon me. I'm not sure why my computer is hanging right now. Okay, So the sales table, what's happening? Okay, so we have the sales table right here that contains the sales of, different employees, right? Contains the sales of different employees. So I just brought up these two tables just for you to understand how join works, all right? These are the two tables we're going to be working with. So if I jump back to Tableau, I'm going to preview these two tables. This is a sales table. This is what it looks like. Of course, as you could see on Excel, and this is a contract table, as you could see on Excel. So when we are talking about the concept of physical layer and logical layer, right? Data joining occurs in the physical layer of Tableau, right? So when you open the Tableau connection editor, this is a connection editor, right? What we have here is what we call the logical layer. This is the logical layer, and the logical layer is composed of separate tables, distinct tables, right? And each table in the logical layer is made up of different tables, at least one table in the physical layer. Very interesting. Now, the question is, where is the physical layer? Join occurs in the physical layer, not the logical layer. Now, this is a table in the logical layer. Like I mentioned, the first UI you see, the user interface you see when you open your connection editor is the logical layer, right? In order to go to the physical layer, right, where join occurs, if you over this, you see, double click this logical table to see its physical table. Now, if I double click on this, it takes me to another UI. Now, this is where join occurs. Now, I'm going to close this. Once I close this, I come back to the logical layer. Now, this is a single table in logical layer. If I want to go to the physical layer, I double click, it takes me to the physical layer. Now, this is exactly where join occurs. Now, I have a contract table here, and I want to join the contract table to the sales table. Because, of course, if I drag this here, voila, look at what happens. We have something like a Venn diagram here, and then we can choose the type of join we want here. Like we mentioned, we're describing our sets, different types of joins here. So now I can select the basis upon which I want to do my joins, right? So like I said, before join can occur, there must be a linking field between the two tables. Now I'm going to select my linking field. What linking field do we have here? Just because I know the data set very well. It is ID linked to employee ID. And what do we have? Now the two tables are joined. When I want us to join based on the records that match, of course, all the records from the tables, do they match? I'm not very sure. We'll see that in a bit. Right here, we have the two tables joined together. And then if you close this, look at what happens. We have a single table with an icon behind it, with a Venn diagram icon behind it, which means that this table is actually made up of two or more tables, right? So if I want to see the makeup of this table, I can double click it. So the concept of logical layer and physical layer is just like, as humans, right, we are composed of different systems, which is our physical layer. We are composed of, the skeletal system, the digestive system, the reproductive system, the digestive system, and so on, right? So that is the physical layer. But what you see from the outside is the logical layer. All right. So, this is like the system man is composed of. And then, if you come outside, you're just going to see the full man, which is composed of a lot of systems, right? So that is exactly how joining works. Now we have one single sheet, containing all of the joins. We could have different sheets, 5 sheets, 10 different sheets or more joined together. At the end of the day, they are going to give us a single sheet in the logical layer. So right here, we have a logical layer. So this is exactly how join works. So now, in order to practice different types of join, it's actually, probably don't have a lot of time to do this, but you just click on the Venn diagram, then we can start exploring. Like I said, if you look at the left join, it's, and you come down to the table, you'd see that, we have a Bisola here, which apparently doesn't have a match on the other table, which is the sales table. As you can see, there are nulls here. But then Tableau has preserved all of the records from the left table, which is the contract table. but then only brought in the matching records from the right table. If we try the right join, let's see what happens. Scroll down. Okay, so we can see that all records from the left table actually match the records from the right table actually match records from the left table. And if you use the full outer join, the full outer join now is just like you're using the left outer join, because all the records from the right table matches records from the left table. All right, so we can go back to using an inner join and then come right out. So that is exactly how join works. All right, so now we are going to look at how the next topic, which is um relationships. What are relationships, right? So relationships is combining two tables too, just like something like join. But now this time, your two tables retain their structures, right? The two tables you're joining, they remain their they maintain their structure. So it's like there's a contract between two tables, right? And then for this, just like the first table, table A says, "Hey, table B, I have a business, right? I have my table, but I want you to come in because I know I like what you do. I like your own table. But this time we're gonna have a contract between us. We're not going to join our enterprises. Our two businesses are not going to join. You're going to have your business. I'm going to have my business. But when I need your help, you promise you come through for me. And when you need my help, I promise I'll come through for you." So that is exactly how relationship works. So that is the reason why relationship does not exist in the physical layer like joins. Because the two tables do not join together to form one table. The two tables retain their structure. They retain all of their rows. They retain all of their columns. All right. So I'll show you how relationship works. Right. So now we're still going to demonstrate relationship with these two tables. So I have my contract here, my contract table. And now, I don't have to go down to the physical layer. I am doing relationship this time. And I bring in sales to the screen. Now look at what happens. Instead of us having the Venn diagram that shows, we have something here called the noodle. So if I drop sales here, it's showing this sign, which means that sometimes when you do this, automatically Tableau helps you join based on records it believes are matching records. But sometimes Tableau is just unable to decipher this record, so you need to choose. Sorry, is unable to decipher this matching fields, right? So you need to select this matching fields. So one similarity that relationship has with join is, for relationship also to occur, there must be common fields between the two tables. There must be a linking field between the two tables, right? So now I'm going to click on this noodle and come down here to select the linking field between these two tables. So like we selected, it is ID to employee ID, right? And then we have it. So like I mentioned, these two tables retain their structure. If you remember, while we are doing joins, right, the two tables combined in the physical layer and came up to the logical layer as a single table. But now relationship, everything is occurring in the logical layer. So if you click on the first table, you see it retains its structure. If I come to another table, the sales table, you see it retains its structure, and all of its rows, all of its columns are retained. So we've mentioned the similarities between relationship, which is the first one is, you're combining two tables with the both of them. Another thing is, for these two to occur, there must be a linking field between the two tables involved, right? Which I've actually established. Now, what are the differences? One of the differences between these two is relationship is dynamic, right? Because the two tables are not joining. So it is dynamic. The two tables, it is at the point of visualization. They explain what they want to do. It's a contract between them. So the table here says, "Hey, table B, come. I want to have this kind of visualization, but I don't have this field. Can you just borrow me this field?" And table B says, "Okay, no problem, bro. Since we both have that, we both had that agreement that this is what is going to happen between us. Take it and you're going to have it." So it is very, very dynamic. They have this dynamic relationship. What is happening between them is not a join. They don't join. They relate. Pardon me. They do not join. What they do is they relate, right? That is one difference between join and relationship. Another difference between join and relationship, when you're doing relationship, you do not need to select the join type. You do not need to select the join type. Tableau does all of that for you. I mean, at the point of visualization, like I said, it is very dynamic. So at the point of visualization, the two tables would know the exact way to actually, combine the two tables for you. Another thing is, for relationship, all of the records, since you are not selecting the type of join to use, all of the records are retained. Like all of the records and all of the fields are retained, right? So I mean, and there's one pitfall that join have that relationship actually came to address, because I mean, relationship was, I believe, the newest way of combining data in Tableau. After join, then relationship came, right? But before relationship came, right, join had a pitfall, which the major pitfall was when you use join, there could be duplicates in your data, right? There could be duplicates in your data, and it's going to be very, very hard for you sometime, especially if you're using join for the first time. If you're new to data, it could be very, very hard for you to actually address that issue. But when relationship came, relationship actually addressed that. Now, I mean, I don't want to do a lot of talking. Let me show you what I mean, right? This is a table here. Let me bring these two tables in the same sheet. If I bring this to this sheet, I really do not know why my Excel has been hanging. Okay. Just give me a few sec. So basically, right now, if I come to this sheet, I come to sheet 2, and I am trying to, let me say I have my employee ID here on rows. I have all of my employee IDs here, and I'm trying to look at the sales of this employee. I'm looking at the sales of this employee, and this is what I have. I mean, this is actually exactly what I have on my Excel. I don't know why my Excel is actually, doing this right now. I'm not sure why I'm having this. All right. So, basically right now, these are all of the values. These are the measures I have on my Excel. I mean, this is the sales of employee A. This is the sales of employee B. This is the sales of employee C. Right. And then, I mean, these are the two different tables here. As I said, the two tables were retained because I used data relationship, right? And if I bring, let me say I bring in the contract date here, you can see that somehow, I mean, the measures looks like there's a split because, of course, from the table, the level of detail changed. But then the level of detail of this measure is still the level of detail of the employee ID, right? It's not in the level of detail of the year. So it still retained, I mean, it spreads the same measure across, I mean, across different rows. But then it still doesn't mean that these are duplicates measures. It's still the same measures, right? But then if you're doing this with join, if I take the year away, join somehow actually adds up the two values to make it, I mean, over 18,000, which is actually amplified. But relationship actually works around that. Okay, let me create a new data source to show you what exactly I mean. In my new data source, I am going to do a join instead of relationship and compare the two. So right here, I have my contract. Double click to go to the physical layer so I could join. Then I bring my sales into the screen. ID and then ID. Right, great. Now, if I'm opening a new sheet here, I am trying to do the same thing. So what I'm going to do is I am going to rename my two sheets. This is going to be the join, my two data records, data sources. Right, this is going to be the join, and this is going to be the relationship, just for you to understand. Right, so now, if I'm doing the same thing we did here, now I want to do this is relationship, and this is going to be join. All right, great. So I am dragging the same employee ID here, and I'm dragging sales here. Okay, we're still using relationship, pardon me. Okay, so I still want to use the join. So I'm dragging employee ID here. I'm dragging sales here. Now look at what happens here. Um, what's it called? Join actually amplify their values because these two tables have different level of details. So because I mean join is very static, unlike relationship that is dynamic. Join was seen, I mean, because like I said, these two tables are in different level of detail. Join has actually gone ahead to duplicate all of the measures in the two tables. I am trying to explain this better with Excel, but somehow my Excel won't open. So we're just going to continue with this. Meanwhile, in the relationship still sees them as the same value. Still sees, the sales as the same value. Meanwhile, join has come ahead to, I mean, to duplicate what we actually originally had, which is not what it's supposed to be. So, in order to address this, you would have to write some complex calculations, the LOD and all of that, right? Which is actually beyond the scope of this particular session. Right. So, I mean, that is majorly the differences between relationship and joins. All right. So going back to our slides, the next thing we're going to be discussing is blending. What is blending, right? Blending, just like join and relationship, blending is a way of also combining data between two tables. But this time, these two tables are from two different data sources. Interesting. So blending is used for combining data across two different data sources. Like I'm working with a data source right now, and in the middle of my work, I realized that I need to, work with another data coming from another data source. At this point, I'm going to use data blending. And unlike join and relationship, right, data blending occurs at the sheet level. Data blending occurs at the sheet level, not the it doesn't occur at the connection editor screen. Okay, I'm going to show you that in a minute. So from the characteristics as well, for data blending to occur, you must have a linking field. You must have a common field between the two tables you're trying to join, the two data sets you're trying to join. And another thing about blending is blending uses the operation of blending uses the logic of the right table join, sorry, the left table join, right? That is the logic it uses in combining two tables. All right, so don't let me bore you with too much of talks. Let's join in, let's dive in, and what I'm going to do, I'm going to close these two tables, so these two data sources, and add new data sources. So for blending to occur, there must be a first data source. So this is what I'll use to demonstrate data blending. So I also have two tables. I have the salaries table and I have the sales table. All right, so we're going to let me drag the sales table here. So I'm going to create a data source out of this, right? Sales table, and I'm going to open the feed. Like I said, data blending occurs at the feed level, right? And it occurs between two different data sources, two or more data sources actually. The first data source is called the primary data source, and the data source that comes in after is the secondary data source, right? So if I drag in my item here, and I drag in probably sales here, right? So I can see the sales by different items. I can sort them. So right now I have sales by different items, right, that were purchased, right? Probably in the middle of my, my analysis or my report, there's something else I need from another data source, right? You could be working with a database, and then another data source you need is from a CSV, a text file, or from an Excel. You could as well have, two different Excel data sources. You could have different data sources. So right here, this is a data source, right? Now I'm going to add another data source. To add another data source, you can easily just do that, by clicking on this icon here. You can as well come to data and select new data source here. So what I'm going to do is I'm going to click here, come here, I'm going to select the same sheet and then create another data source from it. All right, great. So this is another data source here, which we've created here. All right, so this is going to be our secondary data source. We're going to go to the same sheet And you see here we have two different data sources. We have the salaries data source, and and not this the sales data source, and we have the salaries data source. Pardon me. Now, what I have on the screen right here, was from our primary data source. Now, another thing I want you to know is when talking about data sources, the first data that comes, that you import necessarily doesn't automatically become your data source. What defines a primary data source is the data source from which you drag it through to, a canvas here to make a visualization. All right. So what I'm saying is, even though sales was the first data source I imported, if I come to salary and drag sales from salary to the screen, salary automatically becomes my primary data source. And as you can see, a primary data source is represented by this tick mark here, this blue tick mark. All right. Again, if I come to sales and I drag items to the screen, this sales automatically becomes my primary data source to which I am about to blend another data source, right? And the primary data source is represented by this blue tick mark here, while the secondary data source is represented by an orange tick mark, which we're going to get to, right? So now we have this. If I can drag my sales here, now we have this item by the sales amount here. If I come to my primary data source, sorry, my secondary data source, which is now salary, right? It's going to look at, what is the linking field between these two tables? It hasn't blended yet, but it wants to know the linking field between these two tables. Now, the linking field is represented by this icon, right? This icon has a slash right here. If I want to enable it as a linking field, all I have to do is just click it. Now it has become a secondary data source. As you can see, it now has this orange tick mark here, which means that sales is my primary data source and salary is my secondary data source. Great. Now I can decide to move salary to the view, make this discrete, and then I have salary on the screen, which is great. So I have been able to blend my salaries, I've been able to blend my secondary data source into my primary data source. Another thing you should know about data blending is data blending operation is a sheet per sheet operation. All right. So right now, unlike what's it called, relationship and join, that you define them at the data source level, this is defined at the sheet level. So right here, I can have a primary data source on this particular sheet, and another particular sheet have another primary data source. Salary can now become my data source on this sheet. Salary can become my primary data source on this sheet, right? So as you can see, on this sheet, salary is my primary data source, while on this sheet, sales was my primary data source. Right, great. So another thing I was trying to explain is primary data blending actually, when you're using data blending, it aggregates records from the two different data sources, right? So data blending is more of an aggregated operation of combining data, right? So what do I mean by that, right? So like I said, I have my primary data source already on the screen. This is my primary data source, which is great. If I go to my secondary data source, right, let me show you this well on Excel. This is my data blending sheet. I really hope Excel cooperates this time. All right, so I have two different sheets here. This is the sales table, still the same thing. Sorry. So I guess Excel is not working. We're still going to come here. All right, so I have a sales table here, which is a record, an item to a value, an item to a value, an item to a value. If I take this away, right, let me clear this and use this. But for the salary sales, for the salary here, what we have is also a record to a value, a record to a value, a record to a value. But one thing here, right, is that um, both tables, they have the same, do they have the same I mean, do all the records from the two tables match? I don't think so. Now, if I come to this and I bring names here, you see that, I mean, Joseph is in the right table, it's in the left table, but it's not in the right table. I mentioned that a data blending operation actually uses the logic of left table join. As you can see here, Joseph, I mean, somehow all of the records here were preserved because, I mean, the primary data source is my left table because it's using the logic of left data join. So the primary data source is my left table. That means it has retained all of the records here, even though some of the records or one of the records at least do not match with all of the records in the right table. Now, if I bring the names field from here and bring it here, you can see that Joseph actually do not match with any record here, but it has somehow retained Joseph. It has retained Joseph. Now, what we are going to do is now let's go the other way around and use sales as the primary data source. Now you see that there's no Joseph here because I mean, Joseph does not exist in the sales table. And now we are trying to use this as a secondary data source here. Let's see, did Joseph come up? No, Joseph did not come up, right? But then one thing we notice is Michael actually exists and Michael does not exist yet. Somehow using the logic of the left data join by retaining all of the records from the left table and only matching records from the right table, which is great. So that is one about data blending. So finally, we are going to touch data unions, right? So what is data union? What is data unioning? Data unioning is an operation that allows you combine data or different tables, but this time you're combining these tables vertically, right? You're layering one table under another table, you're appending tables, right? So it's like we have a table here, we have another table here. I mean, the two tables have the same column. They have the same column types. They have the same, data types, and then the naming convention of those two different columns are the same. And somehow you've successfully, brought this table under another table. That is unioning. So union is a method of vertically combining data where a table is appended under another table. And for union to happen, the headers and data types of the primary table must be the same as what is on the incoming table. So let us demonstrate that briefly. So like I did before, I'm going to close this. I'm going to close this. I'm going to add a new connection. I'm not really sure why my computer is dragging today. It's done so much work lately. All right, so here we're gonna have I have this particular data for data union. So we have different sheets here, right? We have a year 10 sheet here, and we have, it contains students' name, their gender, and their courses, right? And then we have another sheet here that contains year 10 students. So basically, we are still talking about students here, but these students are from different years, still students, gender, and courses. So what we want to do right here is to append these two tables. We want to, combine these two tables vertically. We want to place the year 11 under the year 10 or year 10 under the year 11 tables, right? So how do we do this? Now we have a year 11 table already on the screen on the connection editor, data connection editor. What we're going to do next is bring the year 10 sheets. Now we're not placing it by the side. What we're going to do is we're placing it under the other sheets because we want it to actually stay under it. And once you place it under, you see the union. You see an orange box comes under the first primary table and says union. Then you're going to drag it inside and then leave it. Then you see this icon, which is a union icon, and successfully we've been able to union the two tables. As you can see here, it says the table name and feed. You can see year 10, and under year 10, if I increase this to 1000 number of rows I want visible from year 10, you can see this year 11 here, which is great. actually great. So successfully, we've been able to, easily, union two tables. We can decide to union two, three more, 10, 20 different tables. I mean, and we're gonna have them in the same, under the same structure like this, which is great. All right, so we can go into our sheets and then, we can see all of the things we need. So we can have the students and all of the students here. And we can, have the courses the students do. Then we can, you know, do whatever it is, the gender of the students, and then voila. So that is all about, everything we need to discuss for this session. Side, if there are any questions you need to ask, you can always come to ask. Like I mentioned, you can hit me up on my LinkedIn, on my Twitter, and you can as well send me an email, right? So, to this end, I say thank you very much, and hope to meet with you guys again. Once again, my name is Michael Fajamley. Bye bye.